So today let's take a look at what happens when we have two different components in an AC circuit, precisely a resistor and a capacitor. So we have RC series circuit. Okay, we have RC series circuit, and the R here means resistor and a capacitor connected in series in an AC circuit. So consider this an AC circuit given below, like this. So here we have the resistor, and here we have the capacitor. Here we have the ammeter, and then we have an AC source here. Comes down here, we have V and F, of course. Here is R and C. So we have a resistor as well as a capacitor connected in series in this AC circuit. Now, if you watch one of the videos we did when we discussed resistors in AC circuit, we said in resistors in an AC circuit, we know that the current and the voltage, both the current and the voltage in the resistor are in phase. That means they both reach their peak values at the same time, at the same instant of time, you see. So now if you're to use a vector diagram to illustrate the relationship between the current in the resistor and the voltage across the resistor in an AC circuit, you're going to have the two of them in the same direction. IR will be in the same direction as VR. That is while the magnitude may be different, you see. So let's call this one diagram 1, where the two quantities, the current in the resistor and the voltage in the resistor, are both in the same direction, you see. Now similarly, okay, let's put it this way. In capacitors, remember, we know that the current in a capacitor leads the voltage in that capacitor by 90 degrees or pi over 2 radian. Yes, remember we discussed that earlier. Now if you're to represent this information using a vector diagram, you see we're going to have something like this, where the horizontal is going to be the horizontal vector will be the voltage across the capacitor, and the vertical vector is going to be the current in the capacitor. And both theory and practical has shown, or experiment has shown, that both of them are out of phase by 90 degrees, where the current leads the voltage, see, by 90 degrees. Now I want you to remember that experiment has shown that if you have two components connected in series in any circuit at all, be it AC or DC, then you have the same current, the current passing through one will exactly be the same current passing through the other. So we have, remember that so if the current in R is the same time as the current in C, then we say IC is equal to IR, both in magnitude and direction. You see, both in magnitude and direction. In magnitude and direction. You see, both in magnitude and direction. Now, if the current in the resistor and the capacitor are the same, that means, sorry, and the current in in the resistor is in phase with the current is in phase with the voltage in the resistor across the resistor, it means that both VR, that's the voltage across the resistor, will be the same, will be in the same, will be in phase with the current IC. So like here we said, since these two components are connected in series, it means the same current is passing through them, and that current is in the same is the same both in magnitude and direction. You see, so here we said IC is equal to IR both in magnitude and direction. Now if that is the case, and IR is in phase with VR, that is the voltage across the resistor, therefore IC will be in phase with VR. IC will be in phase with VR, and that means in this second diagram here, the second vector diagram here, we can remove this vector here, this IC here, and put VR inside. So we have, so now the vector diagram 2 becomes it looks something like this now. So we have VR and then VC. See, in this case, remove the IC from there and put VR there. And that means the voltage across the resistor leaves the voltage across the capacitor by 90 degrees. It leads it by 90 degrees. Now remember, the voltage of the source here is a sum of the voltage across these two components, the resistor and also the capacitor. So if we have to find the addition of the two, now using vector addition, now you know that if two vectors are inclined are perpendicular to one another, then their sum total, their sum will become the square of each, the sum of the square of each of them. So we have VR squared plus VC squared. Is that taken? So we use, now remember also from Ohm's law that V is equal to IZ, where Z is the impedance in the circuit. We also know that VR is the same thing as IR, this is from Ohm's law now, and then VC is the same thing as I, capacitive reactance, you know, where XC is capacitive reactance. Where X is capacitive reactance. Now, having said all of that, let's call this equation 1, and the whole of this is equation 2. So now putting 2 in 1, we say putting equation 2 in 1, we have, you see, so we have IZ squared is equal to so here we have IZ squared is equal to IR squared plus IXC squared. So if you expand the bracket, we have I squared Z squared is equal to I squared R squared plus I squared XC squared. Collect a common factor. This becomes, we have I squared Z squared is equal to I squared R squared plus XC squared. Now this takes this one away, and so that means we have Z which is the impedance now, is equal to, so Z squared becomes R squared plus XC squared. Now take this one over to the side. We say therefore Z now becomes the square root of the square of the resistor plus the resistance plus the square of the capacitive reactance. So we call this equation 3. Now equation 3 gives the impedance in an RC series circuit, in an RC series circuit. See, so let me explain for the very start. An RC series circuit is that circuit in which you have only a resistor or resistors and capacitors connected in series. You see, so when you consider this kind of a circuit, you know that in R, both the current and the voltage are in phase, while in the capacitor, the current leads the voltage by 90 degrees. Now, since the both of them are connected in series, it means the same current passing through this is what you're going to have passing through this as well. And since these two, that's the current in the resistor and the voltage across the resistor, are in phase, it means that the current in the capacitor and the voltage in the capacitor will be in phase as well. And that means the voltage across the resistor will lead the voltage across the capacitor by 90 degrees, and that's what we have in this diagram here. You see? So now remember that the voltage of the source is the sum of the voltage across these two components, and when we try to do that here, we'll have to use Pythagoras theorem. And so when you do all of that, you substitute the values of V, VR, VC by these equations here, and you try to make Z subject to the formula, you get this one here. Thank you.